Welcome to the debate. If you wanted to boil a single cup of tea in a massive apartment building, you wouldn't power up the entire skyscraper to do it.
No, obviously not.
Right? I mean, you wouldn't turn on the elevators, fire up the HVAC system on floor 80, and activate the parking garage gates just to heat up one small kettle of water.
Right, because that would be a catastrophic waste of energy. You just, turn on the kettle. You isolate the power to the exact appliance that needs it.
Exactly. But when we look at the current state of artificial intelligence, these massive monolithic large language models that process our daily queries, we are essentially powering up the entire skyscraper every time we ask a simple question.
We really are.
And right now, our global energy grid is basically buckling under that weight. We are facing a severe energy and efficiency crisis in modern computing. I mean, data centers are quite literally drinking rivers of water for cooling and consuming the power output of small nations.
It is a massive bottleneck. The sheer compute power required to train and, run these models is hitting physical and ecological walls.
Which brings us to today's focus. Dr. Guy Lakeman has proposed a radical structural solution to this crisis in his conceptual blueprint, the University of Superintelligence.
A fascinating text.
It really is. And the central question we are tackling today is this. To solve this massive energy and efficiency crisis, must we fundamentally restructure artificial intelligence into a cooperative, globally centralized, large concept model, as Lakeman proposes?
And this is where I come in. Is the solution purely found in the pragmatic, decentralized integration of new photonic hardware into our existing computing systems?
Exactly. And I take the position that Lakeman's structural overhaul, this unified, specialized framework that prioritizes ecological evolution over political competition, is absolutely essential to actually maximize the potential of these new high-energy efficient photonic clusters.
And I look at it completely differently. I contend that the true pragmatic path forward is strictly hardware-driven. The real revolution is in the physics, not the sociology. Photonic accelerators already solve the efficiency crisis seamlessly within existing computing architectures, which renders a utopian global restructuring unnecessary.
Well, let's dive into that. Let's start by laying out Lakeman's core thesis, because it is as much a critique of our current social architecture as it is of our technological architecture.
Fair enough.
So Lakeman argues that current massive LLMs are inherently wasteful by design. They are driven by what he explicitly calls wasteful human political brinksmanship.
Right.
He argues that the tech industry is just, racing to build bigger and bigger general purpose models just to maintain geopolitical hegemony, or, in his words, for greedy bastards to figure out new ways to sell us things.
A rather blunt assessment of the free market, but I do understand his underlying frustration with the resource allocation.
Blunt, but accurate when you look at the energy bills. So his solution is to pivot away from large language models and build a large concept model, or LCM.
Right.
Instead of one massive model trying to do everything and wasting energy in the process, Lakeman envisions breaking AI down into dedicated specialist silos. So you have a STEM core, a governance core, a humanity core.
Mm-hmm.
You have specific isolated nodes for archaeology superintelligence, ecology superintelligence, and so on. And these are all connected by what he terms a corpus callosum context disperser.
Right, borrowing a term from neurobiology.
Exactly. It functions sort of like CERN or the International Space Station, a massive global cooperative that uses these new photonic inference engines to support planetary evolution rather than aggressive corporate skirmishes.
It's a nice thought.
It is the only logical architecture if we want artificial general intelligence to serve the whole of global society efficiently.
Well, that is a beautiful vision, but the actual breakthroughs we are seeing don't require us to rebuild human cooperation from scratch. No. The efficiency bottleneck in modern computing is being solved right now by manipulating light particles, photons, instead of electrons.
Sure, the hardware's getting better.
It's a completely different paradigm. When we look at technologies like the QANT photonic chip out of Germany, or say the LightGen AI accelerator out of China, they achieve up to 30 times lower energy consumption natively.
Right.
And 50 times faster performance natively through optical interference. And because these chips integrate seamlessly with our existing standards, like standard PCIe interfaces and the PyTorch software developers already use, a centralized CERN-style monopoly is superfluous.
I wouldn't call it superfluous.
We don't need a global university of superintelligence to boil the kettle efficiently. We just need a better heating element, and photonics provides exactly that.
Well, I appreciate the elegance of the physical hardware, I really do, but we cannot divorce the hardware from the software architecture that utilizes it.
But the hardware solves the core issue.
Let's look at the root of the inefficiency, though. Lakeman's blueprint illustrates that a single super-large LLM causes massive energy wastage simply by its structural design. By instituting what he calls silo barrier I/O, we ensure that we only power the domain we need.
Okay, but
If I'm asking a question about global ecology, I'm routing that purely to the ecology superintelligence within the governance core. I am not waking up the literature or art superintelligence. The skyscraper analogy holds perfectly here.
I have to disagree.
Even if you replace all the wiring in the skyscraper with highly efficient fiber optics, turning on the whole building to boil a kettle is still a fundamental failure of architectural logic.
I'm sorry, but I just don't buy that. Let me tell you why. The waste in our current system isn't primarily in the breadth of the model. The waste is in the friction of the medium.
The friction?
Yes, you're diagnosing a software problem when the evidence points to a fundamental hardware limitation. We are hitting the wall of the von Neumann architecture.
Okay, for the sake of clarity, lay out exactly what that limitation is in this context.
Gladly. Traditional silicon GPUs constantly have to move data back and forth between separate computation cores and memory storage. It's like a chef having to run to a grocery store down the street for every single ingredient.
Right, the data transfer bottleneck.
Exactly. And they use electrons to do this. Electrons create electrical resistance, and that resistance generates massive amounts of heat. Cooling those data centers to prevent the chips from melting is where a massive portion of our energy grid goes.
Sure.
But look at QANT's thin-film lithium niobate technology, or TFLN. Because it uses light traveling through microscopic waveguides, there is virtually no electrical resistance. It produces zero on-chip heat.
Okay, before we get too deep into the weeds here, let me stop you because I think people listening might be stuck on one thing.
Sure, what's that?
You keep saying light pipes and no heat. How does a computer actually function without electricity? I mean, how are we doing math with light?
Oh, it's a great question. Think of optical interference like dropping two pebbles in a pond.
Okay.
When the ripples travel outward and cross each other, they create a new predictable pattern where they intersect. By carefully controlling intersecting laser beams that represent different numbers or data points, the ripples of light instantly overlap to form the mathematical answer.
Just by crossing the beams.
Exactly. It calculates natively as the light passes through the chip, no electrons required. Because of this, one single optical element in a QIANT chip can perform an 8-bit multiplication that would typically require 1,200 traditional CMOS transistors.
Wait, 1,200 from just one element?
Exactly. One optical element replacing over 1,000 transistors, generating zero heat and moving at the speed of light. When you have that level of physical efficiency, the software architecture of the model, whether it's siloed into an ecology core or left as a monolithic LLM, becomes a secondary concern. The physical processor runs on light. The medium itself solves the friction problem.
I see why you think that, but let me give you a different perspective. You are solving the friction problem, yes, but you are completely ignoring the synthesis problem.
Synthesis problem?
Yes, AI is no longer just about linear calculations and matrix multiplication. It is about complex, multidisciplinary context. How do we route and synthesize global problems without Lakeman's corpus callosum context disperser?
You think the hardware routing can't handle the complexity without a new organizational structure?
I think the current structure is conceptually flawed. Let's retire the skyscraper analogy and look at it this way. Think of the corpus callosum as a highly advanced air traffic control tower.
Okay.
If we were trying to solve a massive climate infrastructure issue, that requires the ecology superintel, the economic superintel, and the STEM core to all work together.
Right.
If you just have massive decentralized models running on incredibly fast photonic chips, you have thousands of airplanes flying at supersonic speeds, without a centralized tower coordinating them. They will crash into each other.
I think that's a bit of an exaggeration.
You need a dedicated, centralized context hub to synthesize these distinct silos safely. NVIDIA already has the interconnect spine philosophy and high-speed interfaces, sure. But high-speed interfaces are useless if the AI agents aren't structurally unified by a central hub that prioritizes progress over profit.
Well,
without that structural unity, we are just doing the wrong things much faster.
That's a compelling argument, but have you considered the actual real-world deployment data of these hybrid accelerators? We don't have to theorize about a metaphorical air traffic control tower because standard hardware routing already achieves this synthesis elegantly without requiring a global utopian council.
How so?
Let's look at the Quant Native Processing Server, the NPS.
The server they are deploying right now.
Yes, it is actively working today at the Leibniz Supercomputing Center in Germany. It acts as a hybrid accelerator. It skips the digital detours by encoding data into laser beams to solve the heavy, power-hungry math, like the matrix multiplications needed for visual AI and complex scientific simulations.
Okay, but it still has to interface with the rest of the system.
Right, and here is the critical part. It doesn't try to reinvent the entire computing ecosystem. Once the light calculates the heavy math, the chip routes that data back to conventional digital memory.
So it's translating back and forth between light and electricity.
Exactly. It communicates with existing servers via standard PCIe interfaces. It integrates perfectly with modern software stacks like TensorFlow and PyTorch. If an AI researcher at Leibniz is trying to simulate a climate model, they don't have to submit their query to a global ecology core governed by an international body.
But that's exactly...
They just run their Python code, the server offloads the heavy math to the laser chips, gets the answer instantly with near zero energy cost, and feeds it back into the standard system. We have high-speed interfaces and hybrid routing. The synthesis happens natively at the server level, utilizing the tools and frameworks developers already know.
But relying on our existing systems, our existing server frameworks, and decentralized, profit-driven deployment is exactly what Lakeman is warning us against.
Really?
Yes. This brings us perfectly to the geopolitics of this progress. Lakeman explicitly notes that cyber intelligence systems at major corporations and within competing nation-states are already showing competent, more than human intelligence.
Right, the AI arms race.
But if we don't adopt a dedicated collective approach, like the ISS or CERN, we remain trapped in what he accurately describes as a multiple energy-wasting competition of self-appointed elites.
You think the current development model is inherently dangerous?
I think it's catastrophic. If we just plug these miraculous photonic chips into the current global system, we accelerate the very hegemony Lakeman fears.
How so?
We make the system faster for people making money out of killing machines, which causes loss of funds, which causes starvation and misery. The structural overhaul, the University of Superintelligence, is a prerequisite for making sure superintelligence actually serves planetary evolution and global ecology. If we leave it up to the current supply chain reality, we are just supercharging our own destruction.
I come at it from a different way. Look closely at Lakeman's own argument for global cooperation. There's a massive contradiction there.
A contradiction?
Yes. The only reason we even have these photonic chips is because of the very national competition he wants to get rid of. The massive leaps we are seeing in photonic integrated circuits are happening specifically because of strategic national competition, not in spite of it.
I wouldn't call the current state of semiconductor embargoes a healthy ecosystem for scientific progress.
Healthy or not, let's look at the data. Chinese researchers are advancing these photonic chips as strategic alternatives to traditional silicon semiconductors precisely to avoid reliance on restricted Western semiconductor equipment.
Okay.
They are not doing this to sing kumbaya at a global university. They are doing it for strategic autonomy.
But that is exactly the wasteful brinkmanship Lakeman is trying to bypass. The whole point of the large concept model is to remove national ego from the development of AGI.
Is it wasteful, though? Because the output is staggering. Scientists at the Shanghai Institute of Microsystem and Information Technology just demonstrated techniques to mass-produce optical chips using lithium tantalate.
And what exactly does lithium tantalate change?
It changes the economics completely. Previously, the specialized materials needed for optical chips were incredibly expensive and hard to scale. Lithium tantalate is a material that performs brilliantly for optical waveguides, but can be processed using standard commercial wafer manufacturing.
So it's cheaper.
It lowers costs dramatically and allows for mass commercial production. And look at the manufacturing side. The chip hub in Wuxi operates a national pilot line capable of producing 12,000 6-inch thin-film lithium niobate photonic wafers annually. They are actively localizing a supply chain that previously sat below a 5% localization rate.
So they are building an entirely self-sufficient parallel supply chain for optical computing.
Exactly. And you have companies providing high-speed assembly for co-packaged optics.
Right.
That's another crucial term. Co-packaged optics means bringing the fiber optic light directly to the processor chip in a single package, eliminating the energy loss traveling across traditional copper wires on a motherboard.
Right, shrinking the physical distance.
This entire hardware revolution, the LightGen AI accelerator at Tsinghua University that reduces latency drastically, the optical quantum chips developed by ChipX and Turing Quantum that accelerate AI workloads up to 1,000 times faster. All of it is driven by intense geopolitical competition and the need for localized supply chains.
Well,
the engine of this technology is competition. To demand a centralized CERN-style monopoly is to fundamentally misunderstand how this hardware is actually being forged.
look, I don't disagree that competition has driven the initial manufacturing surge. The engineering breakthroughs with lithium tantalate and co-packaged optics are undeniably impressive, and the manufacturing edge clearly resides in these competitive hubs right now.
Right.
But that is exactly why the transition to a large concept model is so urgent.
Because the hardware is moving too fast?
Because the capabilities are scaling far beyond our governance structures. The fact that companies can now put scalable optical quantum chips into standard data center racks, accelerating workloads 1,000 times faster, should terrify us if that power is left entirely to fractured, competing geopolitical blocks.
Terrify us?
Think about what we are actually scaling. If we are scaling systems designed to fog the internet of users, as Lakeman puts it, into political brinkmanship, then the physical efficiency of the photonic chips only hastens our societal decline. We just build faster equichambers and more efficient autonomous weapons.
I think that's a fairly pessimistic view of how decentralized technology gets used by the public.
It's a realistic view of how unsupervised tech scales. Lakeman's model introduces the Internet of Users connecting to an AGI that is strictly governed by the specialized silos. The governance core, which handles medicine, law, and ecology, acts as a safeguard.
But
without the silo barrier I/O preventing cross-contamination of competitive, profit-driven motives into the ecology or humanity cores, the raw speed of light-based computing becomes a weapon, not a tool for evolution.
But the mechanism of optical computing itself actively democratizes the power, which removes the need for such a heavy-handed, centralized governance structure.
How does hardware democratize AI? The big companies will just buy up all the lithium tantalate wafers.
Because it fundamentally shrinks the physical footprint required to participate in advanced research. Traditional supercomputers require massive power plants, specialized real estate, and rivers of water for cooling.
Sure.
It restricts high-level AI research to trillion-dollar tech giants and sovereign governments. But because Q-Ant chips produce near-zero heat and drastically increase computational density, again, that one optical element replacing 1,200 transistors, you fundamentally lower the barrier to entry.
I mean, yes, it's smaller, but
You don't need a monolithic global organization controlling access to a massive supercomputer, because high-performance computing becomes vastly more accessible to universities, smaller labs, and startups.
so you are saying the hardware efficiency negates the need for a central authority?
Precisely. The Leibniz Supercomputing Center is just one example. When a university lab can run complex visual AI and scientific simulations on standard racks utilizing PyTorch, without the massive thermal overhead, you empower researchers everywhere to solve these problems natively.
I see.
You don't need to force everyone into a theoretical university of superintelligence to manage the energy crisis or solve climate change, because the hybrid accelerators resolve the energy crisis natively at the hardware level. The power is distributed, which is historically a much stronger safeguard against tyranny than a centralized global council.
I hear your point, but I firmly maintain that while photonic hardware provides the necessary physical efficiency, Lakeman's large concept model provides the necessary architectural efficiency.
We'll have to agree to disagree there.
Geoffrey Hinton famously said that plumbers will keep their jobs in the age of AI. Lakeman smartly adapts this, noting that tomorrow's plumbers will be plumbing light pipes. But even if you have the most perfectly engineered zero-heat light pipes in the world, you still need an architect to design the building they go into.
That's a fair analogy.
If we just plug faster chips into a broken adversarial system, we aren't evolving, we are just accelerating. Only a globally integrated silo-based structure connected by a true context hub can safely wield superintelligence to serve global ecology and quality of life. We must say goodbye to the era of fragmented AI development and step toward a pragmatic structure designed purely to serve planetary progress.
And I maintain that the deployable reality of QAnt and LightGen processors proves we don't need a utopian overhaul to solve the problem in front of us. We don't need to rebuild the social and architectural framework of the internet from scratch.
The pragmatic reality is that massive parallel processing via light particles elegantly solves our data center energy crises within the systems we already use today by offloading heavy math to photons and routing the results back to conventional digital memory. We achieve unprecedented efficiency. And we do it without needing to dismantle the competitive engines of innovation that actually built the hardware in the first place.
It is clear that the tension between idealistic structural overhauls and pragmatic hardware integration remains unresolved.
Very much so.
As algorithms and photonics continue to merge at an astonishing rate, we are forced to ask whether our current competitive structures can handle the speed of light, or if a totally new architecture is required. There is much more to explore in how hardware shapes the future of AI.
Absolutely. The fundamental physics of computing is changing beneath our feet, shifting from the electron to the photon. How we adapt our society to that physical reality is the defining challenge of the decade.
Thank you for joining us today. As we step back and look at the massive, energy-hungry infrastructure of artificial intelligence, we are left with a lingering question. Even if we successfully invent the perfect zero-heat fiber optic heating element, will we ever figure out how to stop powering up the entire skyscraper just to boil our tea?